This is the how-to video for problem 43 out of chapter 26, and this asks you to find the net force on this positive 1 nanocoulomb charge in the middle of the structure. And right away you can see that the net force is going to be 0 newtons. And the way you can see that is because it's in a square, in the center of a square, surrounded by equal magnitude charges, all of the same sign. These are all negative and this is positive, so they all are attracted to the center with the same magnitude, and the directions ended up making them cancel out. But we will go through the calculation of one of them just to show how you would do it, in case you could not assume that. So we'll go through the calculation for figuring out the force OA. And as we can see from this equation here, the force on a charge, OA, is a constant K times Q1, which we can say is a positive charge. We'll do the absolute value to be safe so we don't end up with any weird negatives. And then times Q2, which is the negative charge, dotted with the r hat unit vector over the radius squared. And the radius, which is this distance here, of course, we can find out easily by saying that it is the square root of 0.5 squared plus 0.5 squared, which equals 0.707 centimeters, which you can convert to meters. Say it's 0.00707 centimeters. Plug that in back into here. We can find that the magnitude, we'll just do the magnitude first, it's equal to K times 1.0 nanocoulombs, negative 2 nanocoulombs, over 0.00707 meters. It should be meters squared. This comes out to 3.6 times 10 to the negative 4th newtons. And the next step, to find the r hat, which is this vector here, r hat equals 0.5i, goes 0.5 to the right, minus 0.5j, because it goes 0.5 down, over the square root of 0.5 squared plus 0.5 squared. And as we know, this is 0.707, which means that r hat equals 0.707i minus 0.707j. Another way you could have found that is to say that this angle is 45 degrees because these are some equal sides here, and that r hat would be equal to sine 45 or cosine, it doesn't matter, I, minus cosine 45j. Both of these are just as valid. And you plug r hat back into this equation here, so you dot it with the magnitude. So that means that force vector OA equals 3.6 times 10 to the negative 4th newtons, dotted with sine 45, negative cosine 45. I suppose it's not dotting, it's just a scalar multiplication with a vector. And this gives you 2.6 times 10 to the negative 4th I minus 2.6 times 10 to the negative 4th j newtons. And what you would do normally is go through and do that on all the charges, but this, we know that it's 0 newtons. And just to kind of prove that, we know that the magnitude of all the charges are going to be equal. It's going to be 3.6 times 10 to the negative 4th newtons. And we can just write down the r hat unit vectors for each one of them. So we already know r hat OA equals sine 45i minus cosine 45j. R OB equals minus sine 45i minus cosine 45j. ROC equals minus sine 45i plus cosine 45j, and ROD equals sine 45i plus cosine 45j. And so you can see that when you multiply the magnitude by all these r hat vectors and then add these all together, should be unit vectors, add these all together, that you're going to get F net, which equals the sum of the forces O to A, B, C, D. F net will equal 0, make sure you have the vector symbol over it, 0 newtons.